Very good morning, students. The topic which you're going to see today is Newton's law of cooling. Yes. So this Newton's law of cooling, it says with the statement that the rate of loss of heat of a body is directly proportional to the difference in temperature. So this is a rate of heat, loss of heat. Okay. So whenever you write with the term d divided by dt, we'll be saying it as rate of. Okay, so this is q, d divided by dt of q, so it is said to be the rate of loss of heat. Yes, directly proportional to the difference in the temperature, because we are writing with a minus sign in between, is it not? So we are saying that it is a difference in the temperature, so t minus ts. Okay, and we are also writing with a negative sign here. So why we are writing with a negative sign is because as the quantity of heat is lost with the increase in the time increase aga heat enagum, heat will be lost, is it not? So only we are writing with a minus sign here. Okay, so the first equation is dq divided by dt proportional to minus t minus ts. T is said to be the temperature of the object and Ts is said to be the temperature of the surroundings. Okay, so any object, if you consider that temperature is T and the surrounding temperature, it is considered as Ts. Now let us consider an object and this has a mass m and specific heat capacity S and temperature T. This has a temperature T and outside the surrounding the temperature is Ts. If the fall in the temperature is del T in a small time of small del T, then the quantity of heat lost is given by this mass into the specific heat into the change in the temperature. So it is del dt. Okay, so dq is equal to ms into dt. Now both the sides we are going to divide with the term of dt. Okay, so dq divided by dt is equal to ms dt divided by dt. Already we know that dq divided by dt is what? That is equal to minus of T minus Ts. Okay, now take this equation from Newton's law of cooling and we have a term which is proportional. To remove the proportionality, we are introducing a constant. The constant which we are introducing here is A. So minus A into T minus Ts. Here A is said to be the positive constant. Okay, now instead of this dq divided by dt, substitute this value here. So we get minus a into t minus ts is equal to this term as it is ms dt divided by dt. Now the next is bring this dt this side and this t minus ts we are going to bring it down here, and same way ms we have to bring it down. Okay, so ms bring it down, ts bring it this side and dt also bring it to the other side. So we get dt divided by t minus ts is equal to minus a divided by ms into dt. Now we are going to integrate on both the sides, integration and integration, and here we are taking the limit of 0 to infinity and here we are taking the limit of 0 to t, small t. Okay, so this is 0 to infinity and this is 0 to t. Next is, and already we know that any term that is 1 by x, if you integrate, the value is ln x. Okay, log x or ln x. Same way, this term can be written as ln of t minus ts, which is equal to, in this, a divided by ms is constant, so we are writing it as it is. If you integrate with dt, so what is the value for integration of dx? Integration of dx is equal to x, is it not? Same way, integration of dy is equal to y, and here we have with integration of dt, that is equal to what? T. So t plus b1, so here b1 is said to be the constant here. Okay, yes. Next is, take this ln to the other side. Whenever you are taking ln to the other side, that becomes as e power. Okay, so this side we have just t minus ts because we have brought ln to this side, so it is e power minus a divided by ms t, then plus e b1, because this also you are writing as e power. Okay, then this e b1 can be written as b2 here. Okay, so e b1 is written as b2, then this term as it is, then Ts we are going to bring it to other side. Here we have minus Ts. When you are bringing to the other side, it becomes as plus Ts. Okay, so T is equal to Ts plus B2 into e to the power of minus A divided by ms into T. Here B2 which is equal to e to the power of B1, and that is a constant value. Okay. Next we are going to see is about the laws of transfer of heat. There are various laws which are based on the transfer of heat. First one is Stephen-Boltzmann law. Stephen-Boltzmann law states that the total amount of heat energy radiated per second per unit area. So we are considering a unit area, and for 1 second, for 1 second for 1 unit area, how much amount of heat energy is passing. Okay, if you calculate that, that energy is proportional to the fourth power of its absolute temperature. So absolute temperature oda fourth power. Okay, if you see that, that will be proportional to it. Okay, so it is a total amount of heat radiated per second per unit area of a black body. You are considering a black body, and that is proportional to the fourth power of absolute temperature. Okay, so we are writing this E proportional to T power 4. Now to remove the proportionality, we are introducing a constant. The constant which we are introducing here is sigma. Since it is a Stephen-Boltzmann constant, this is called as a Stephen's constant. Okay, and the value of this sigma is 5.67 into 10 power minus 8 W m power minus 2 K power minus 4. Okay, so this is the value of Stephen's constant. Okay, yes, this is about the Stephen-Boltzmann law. Clear? Next we are going to see is about the Wien's displacement law. So what is the statement of Wien's displacement is the wavelength of maximum intensity of emission of a black body radiation. So ஒரு black bodyல இருந்து எவ்வளோ emit ஆகுது அப்படின்ற wavelength பார்த்தீங்கன்னா that is inversely proportional to the absolute temperature. Okay, so lambda m ஏன் எழுதிருக்கோம்னா maximum அப்படின்றதுனால. Okay, so wavelength of maximum intensity. Okay, so lambda m proportional to 1 by T. Now to remove the proportionality, the constant which we are introducing here is B. Since this is a Wien's displacement law, B is to be the Wien's constant, and value of this is 2.898 into 10 power minus 3 mK. Whereas Stephen's constant, the value is what? 5.67 into 10 power minus 8. Here this is 2.898 into 10 power minus 3. Yes, clear. Next we are going to see is about the thermodynamics. Thermodynamics we know already. Yes, and there are few branches in that. First, zeroth law of thermodynamics. Zeroth law states that if two systems, so consider the two systems, okay, A and B. ஸோ இந்த ரெண்டு சிஸ்டமே வந்து தெர்மல் ஈக்லிபிரியமில் இருந்துச்சு அப்படின்னா தென் இஃப் யூ கன்சிடர் வித் தேர்ட் சிஸ்டம் தட் இஸ் ஆல்சோ இன் தெர்மல் ஈக்லிபிரியம் வித் ஈச் அதர். ஓகே, ஸோ if two systems are in thermal equilibrium with a third system, then A and B are thermal equilibrium. So sorry, இது ரெண்டும் A and B வந்து third system ஒரு thermal equilibriumல இருந்தா then இது ரெண்டுமே thermal equilibriumல தான் இருக்கும் அப்படின்னு சொல்லியிருக்காங்க. Okay, so this is zeroth law of thermodynamics. Next is internal energy. So what is meant by internal energy is it is the sum of kinetic and the potential energy of all the molecules of a system. So ஒரு சிஸ்டம்ல இருக்க எல்லா molecules-ஓட kinetic and potential energy sum பண்ணோம், that is add பண்ணோம் அப்படின்னா that gives your internal energy. Okay, then we have the first law of thermodynamics. The first law of thermodynamics, it is a statement, it is based on the conservation of energy also. So change in the internal energy is equal to the heat supplied by the system minus the work done. So that is given by del U, which is equal to Q minus W. Here del U denotes the change in the internal energy. Okay, then Q denotes the heat, and W is what? W is said to be the work done. Yes, clear. Here del U is the internal energy, Q is the heat, and W is the work done. So அப்போ internal energy ஓட definition என்ன சொல்றோம் அப்படின்னா இது பேஸ் பண்ணி தான் நம்ம first law of thermodynamics சொல்றோம். என்னன்னு பார்த்தீங்கன்னா internal energy is equal to the change in the, okay, or the heat supplied minus the work done. Okay, Q minus W இல்லையா? ஸோ Qன்றது என்னது? Heat supplied minus the work done அப்படின்னு சொல்லியிருக்காங்க. If suppose the heat flows into the system, ஒரு சிஸ்டம்குள்ள heat flow இருந்தது அப்படின்னா, then the internal energy increases. If the heat flows out of the system, then the internal energy decreases. Then work is done on the system. System மேலே work நடந்தது அப்படின்னா internal energy again increases. Work done by the system. System work பண்ணது அப்படின்னா then the internal energy decreases. Okay. These are the 4 conditions for the internal energy. Okay. Next is a quasi-static process. So what is a quasi-static is, consider a system of an ideal gas which is kept in a cylinder. Consider a cylinder. It has a volume V and the pressure P and the temperature T. When the piston is attached to the cylinder, it moves outward. So இதில் ஒரு piston attach பண்ணியிருக்கோம். இது வந்து outwardல move ஆகுதுன்னு consider பண்ணிக்கிறோம். The temperature and pressure will also change because all the variables P, T and V are related by the equation PV is equal to NKT. So இதில் நம்ம வந்து pressure மட்டும் change பண்ணாலே என்ன ஆகும்? எல்லாமே change ஆகும். Pressure, volume and temperature, everything will change, is it not? And if a block of some mass is kept on the piston, so in the piston மேல ஒரு block வைக்கிறோம் அப்படின்னா, what happens? It moves downwards. Pressure near the piston will be greater than the parts of the system. So இந்த piston மேல இருக்கிற pressure அதிகமாக இருக்கும், இங்க இருக்கிற pressure கம்மியாக இருக்கும். So the gas is a non-equilibrium state. So ஒரு gas வந்து என்னது? equilibriumல இருக்காது. Okay. Then we cannot determine the pressure, temperature and the internal energy until it reaches equilibrium. So நம்மளுக்கு pressure, temperature எல்லாமே ஈக்குலிபிரியம்ல இருந்தால் தான் நம்மளால் டிட்டர்மைன் பண்ண முடியும். If the piston is pushed very slowly in every stage, it is in the equilibrium. ஸோ ஒவ்வொரு தடவையும் ரொம்ப கம்மியாக கொண்டு போனோம் அப்படின்னா என்ன ஆகும்? இட் இஸ் ஆல் சேம். ஸோ எந்த இடத்துல இது எல்லாமே சேமாக இருக்கோ, that process is called as a quasi-static process. Yes, clear? Next is we are going to see with work done in the volume changes. Okay, consider a gas container. So this is a gas container. This is of cylindrical shape and this gas in the quasi-static process. Okay, then what is the formula for work done? Work done is equal to force into distance. So F into dx. Since here distance is dx, then force is equal to what? Pressure into area. Substitute this value of force here. So PA into dx. Yes. Now this A into dx can be written as volume. Yes, so we can write P into dV. Now integrating on both the sides, so we get W which is equal to integration of P into dV and the limit is Vi to Vf. Suppose work is done on the system, then Vi is greater than Vf, அப்போ work done வந்து நெகட்டிவா இருக்கும்னு சொல்லியிருக்காங்க. Okay, so here also the pressure will not be same. Pressure is not always constant. Okay, so this is the work done in the volume changes. Yes, next is the PV diagram. So what is meant by PV diagram is, it is a graph between the pressure and the volume. So pressure kum volume ku nadula graph varairadha enadhu PV diagram. Okay, and it is also used to calculate the work done. So idu vandu work done inge in the shaded portion irukliya, that portion area under the PV diagram gives the work done during the expansion or the compression. Okay, so in the shaded portion na it gives a area அப்படினு சொல்லிருக்காங்க. Okay, then next we are going to see is about the specific heat capacity. This specific heat capacity you would have studied already, is it not? So what is meant by specific heat capacity is the amount of heat energy required to raise the temperature of 1 kg of substance. Suppose you consider 1 kg of substance. இந்த 1 kg of substance க்கு வந்து என்ன பண்றோம்னா, நம்ம வந்து heat supply பண்றோம். So எவ்வளவு அளவுக்கு நம்ம heat supply பண்ணா அந்த substance ஓட temperature வந்து 1 Kelvin or 1 degree Celsius அப்படின்னு நம்மளுக்கு வந்து அது கன்வெர்ட் ஆகுமோ அந்த டெம்பரேச்சருக்கு, அதுக்கு பேர் தான் என்னது? ஸ்பெசிஃபிக் ஹீட். ஓகே, அண்ட் திஸ் கேன் ஹேப்பன் இன் டூ திங்ஸ், எதர் அட் கான்ஸ்டன்ட் ப்ரெஷர் ஆர் அட் கான்ஸ்டன்ட் வால்யூம். ஸோ த அமௌண்ட் ஆஃப் ஹீட் எனர்ஜி required to raise the temperature of 1 kg of substance by 1 Kelvin or 1 degree Celsius by keeping the pressure constant, that is called as specific heat by constant pressure. அதுவே வந்து volume constant அப்படின்னா it is constant volume. Next is molar specific heat. So what is the difference between this specific heat and molar specific heat is, specific heat we are considering with 1 kg of substance, okay, and in molar specific heat we are considering with 1 mole of substance. Okay, so it is the amount of heat energy required to raise the temperature of 1 mole of a substance 1 Kelvin or 1 degree Celsius. Okay, so for this these equations are very important. First equation is Q is equal to mu CV into del T. Okay, Q is equal to mu CV into del T. Next is Q is equal to del U minus 0. Okay, next del U we can write it as mu CV into del T, because minus 0 means this is the same, is it not? So del U is equal to mu CV into dt. From this, if you want CV alone, bring this del T and mu down. So we get 1 by mu into del U divided by del T. Instead of del, we can also write as d. Okay, so CV is equal to 1 by mu into dV divided by dt. Clear? So next question is a very important question, which is Meyers relation. Okay, so for this, consider mu mole of a gas which is in a container, and this has a pressure P, volume V, and the temperature T. And consider that no work is done, and if CV be the specific heat capacity, we know du is equal to mu CV into dt. இது இப்பதான் பார்த்தோம் இல்லையா? Suppose if you consider for constant pressure, then Q is equal to mu CV க்கு பதிலா இங்க CP ன்னு எழுதுறோம் into dt. W is the work done is equal to pressure into this volume, so P into dV, and from first law, so நம்மளுக்கு du கிடைச்சிருச்சு, Q and W. இது மூணு எடுத்துட்டு போய் என்ன பண்றோம்னா, இந்த ஃபர்ஸ்ட் லாவோட ஃபார்முலா Q is equal to what? du plus W. Okay, so Q is equal to du plus W. இதுல Q க்கு பதிலா இந்த வேல்யூ, du க்கு பதிலா இது, W க்கு பதிலா இது சப்ஸ்டிட்யூட் பண்ணிட்டோம்னா we get with this. Yes, and we know with the ideal gas equation, what is the ideal gas equation? PV is equal to nRT. Instead of n, we are writing here as mu here. Okay, now we have to differentiate on both the sides. Okay, so how to differentiate this side is first keeping P constant, differentiating with V. So V differentiate பண்ணா நம்மளுக்கு என்ன வரும்? dV ன்னு கிடைக்கும். Plus போட்டுக்கோ, V அப்படியே வச்சிடணும். P மட்டும் differentiate பண்ணா we get as dP. Okay, which is equal to this side mu and R, they are always constant, so we can just differentiate only with T, so we get dt. Yes, so we are getting PV plus VdP is equal to mu R into dt. Okay, now using this equation in the above equation, and also it is given that dP is equal to 0. dP is equal to 0 na idu full away 0 ஆயிடும். Okay, so PdV is equal to what? Mu R dt. So PdV க்கு பதிலா mu R dt போடுறோம். இந்த equation அப்படியே எழுதுறோம். So mu Cp into dt is equal to mu Cv into dt plus PdV is what? Mu R into dt. Yes, now in this throughout we are dividing by mu. Okay, so if you divide, we get Cp into dt is equal to Cv into dt plus R into dt. Same way throughout divide by dt. Okay, so dt get cancelled, so we get Cp is equal to Cv plus R. Now bring this Cv to the other side, so we get Cp minus Cv, which is equal to R. So this gives your Meyers relation. Okay, so this is very important 5 mark it is. Okay, thank you.